Section 1.5, Quadratic Equations. So a quadratic equation in X, a quadratic equation in X is an equation that can be written in the general form of ax squared plus bx plus c equaling 0, where a, b, and c are real numbers. Most of the time we are dealing ones with integers, sometimes fractions and decimals, but they could be any real number with a not being 0. Again, why can a not be 0? If we put a 0 here, 0 times x squared is 0, so the x squared will disappear, and therefore we're back to just a linear equation. Now b could be 0, c could be 0, a cannot be 0. So a lot of this is review, hopefully, but there are 4 ways that we have learned how to solve quadratic equations. First way is factoring and using the zero factor theorem. You should have covered that in intermediate algebra and introductory algebra. The square root property is also review, completing the square was review, and then the quadratic formula is review as well. So hopefully some of these things will be coming back to you. We'll do quite a few examples, but I will give you quite a few to try on your own. The square root property states that if you have some quantity squared equaling a constant. So I've changed the letters a little bit. I don't like to use x here because it might be a trinomial or a binomial instead being squared. But it does have to equal a constant. So if that's true, then when you take the square root of both sides, you either get u equals the square root of d or u equals negative square root of d. So thus u would equal plus or minus the square root of d. You'll have 2 answers. Quite a few students always forget to put that plus or minus when they themselves put in the square root, so be very careful with that step. Now completing the square will come into play in the next couple of sections when we talk about finding the center of a circle. So I do want to review how to complete the square. Well, first things first, you're going to put into the form of ax squared plus bx, but you don't want c on the left hand side. You actually want c on the right hand side, which is not like pretty much all the other problems. We normally like the quadratic equation or quadratic equations to equal 0, not a constant. If a is 1, go on to step 3. If a is not 1, you need to divide every term by a so that the leading coefficient is 1. So we're trying to get a leading coefficient of 1. Then we're going to take half of the b term, then we're going to square whatever that number is that we got, so square it, and then add it to both sides. Now why do we do these crazy steps? Because then we're going to have a nice perfect square that we can factor. So write the left side as a perfect square by factoring. And then use the square root property, which is what we just listed above. So the square root property works great when it is already in the form, or if you want to put it into the form by completing the square. And the last one that we have learned to use is using the quadratic formula. That's what a lot of students will jump to, but it might not always be the fastest, so make sure that it is not factorable before you just use the quadratic formula. The one thing I recommend is getting rid of all fractions. Before you try using the quadratic formula, you want to get rid of fractions by multiplying by the least common denominator. Then I would suggest combining all like terms. Why? Because you need to put it into the form of ax squared plus bx plus c equaling 0. And then we're going to plug it into the formula, which is x equaling negative b, or opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And then we need to make sure we simplify correctly. So this section, 1.5, is using any of those opportunities of solving. You can factor, you can do the square root property, you can complete the square, or you can use the quadratic formula. So if we're going to solve using any method, I want to try, in a sense, the quickest or the easiest. So looking at number 1, if I try and think about factoring, well, the number in front of x squared is a 1, so this would be what we consider the C method. So all we need to do is find factors of 36 that add up to negative 13. So factors of 36 add up to negative 13 would be 9 and 4, with both of them being negative. Because a negative times a negative is a positive, but when I add, I get a negative 13. So this is going to factor into x minus 9 and x minus 4 equaling 0. We're going to use a lot of these techniques later on in the semester, so that's why we're reviewing them now. So set each one equal to 0, because if you're multiplying things that equal 0, then one of them has to be 0. So add over the 9, so we get x equaling 9, or x would equal 4. So we get 2 answers. So I'm going to circle number 2 for you to do, and bring me back the answer for class time. Alright, so let's look at the next page. Number 3, we have 9x squared plus 9x plus 2 equaling 0. Now this was the ones in to do the AC method, we have to start off by multiplying a times c. So 9 times 2 is 18. And then we need to find the factors of 18 that up to my b term. And my b term is 9. Now there are different ways to solve the AC method. So if you know of another way, feel free to use that method instead. I'm just showing you the way that we show in 116 to keep it consistent. So we multiplied a times c and got 18. We want the factors of 18 to add up to 9, which are 3 and 6. Now the AC method takes a lot longer than just the C method. What we have to do with those terms that we found, or those factors, is put it in place of the B term. So we end up with 9x squared. We're going to separate 9x into 3x and 6x. So plus 3x plus 6x plus 2 equals 0. So the first term and the last term stay the same. The middle term gets broken up into the 3x and the 6x. Now why do we do that? Because we have 4 terms, and we have 4 terms, we factor by grouping. So we group the first 2, take out what's in common, group the second 2, take out what's in common. So with the first 2, we take out a 3x, and we're left with 3x plus 1. In the second 2 terms, what's in common is a 2, and we're left with 3x plus 1. Now, right now, those better be the same. Later on, they might not be, and so we'll have to find a different way to solve. But those should be the same, so we're going to take out the common factor, which is 3x plus 1, and what's left is 3x plus 2, still equaling it to 0. So we need to solve, so we're going to set each one equal to 0 and solve. So we'll end up with x equaling negative 1/3 or negative 2/3. So just set those factors equal to 0 and solve. Alright, number 4. We have 5x squared minus 20x equaling 10. Again, the easier way is to look at this and go, well, there's a GCF. There's something in common. So the greatest common factor is a 5x, and we're left with x minus 4 when we take out the GCF. So then we're going to set 5x equal to 0, or we're going to set x minus 4 equal to 0. Now in this one, when we divide by 5, 0 divided by 5 is just 0, so we get x equaling 0. Add over the 4, we get x equaling 4. Again, 2 answers. So I'm going to circle number 5 for you to do, for you to bring back to me. Alright, so number 6, we have x minus 3 quantity squared equaling 36. This is a square root property. A slower way would be to take x minus 3 times x minus 3, multiply it all out, bring over the 36, and so forth. But the quicker way to realize is this is that u squared equaling d. So all we need to do is take the square root of the left and the square root of the right. So when I take the square root of the left, the square and the square root just cancel. Now on the right, the square root of 36 is 6, but I can't forget plus or minus. Why? Because I put in the square root. So there should be the positive answer and the negative answer. So I'm not done. I'm going to break this up into x minus 3 equaling 6, or x minus 3 has to equal negative 6. Add over the 3, we get x equaling 9. Add over the 3, we get x equaling negative 3. Now in my math lab, just so you know, all they want you to do is separate with a comma. So you'd put 9 comma negative 3. I will take it on the test either separated or together. Does not matter to me. Alright, so number 7, I'm going to circle for you to bring back to me. And I want you to realize is it's not factorable. Why is it not factorable? Because there's no factors of 11 that add up to 8. So what will you have to use? You will have to use the quadratic formula. Alright, so I'm going to do number 8 for you. We have 5x squared plus x minus 2 equals 0. This is where we could try the AC method, but the AC method might not work. So what would I do to start off? Well, I would probably jump to the quadratic formula. I'd write the quadratic formula down every single time because the more you write it down, the more you'll remember it. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. On the test, formulas are not given, so you do need to have them memorized. No little cheat sheets, just have it memorized. So a is going to be 5, b is going to be 1, and c is going to be negative 2. There's my a, the number in front of x is my b, and c is my negative 2. So x is going to equal negative 1 plus or minus the square root of, I'm going to take 5 and square it. Did you notice I used parentheses? Yes, because anytime you do a substitution, you use those parentheses because if my 5 was negative, it would need to be being squared as well. So make sure you use parentheses. Minus 4 times a, b is 1. So let's change that. We have b is 1, so 1 squared. Minus 4 times a is 5, times c is negative 2, all over 2 times a, and a is 5. So sorry about that, b was 1. Alright, so now let's go ahead and start trying to simplify. We get negative 1 plus or minus the square root of 1 squared is 1, 4 times 5 is 20, times 2 is 40, and 2 negatives make a positive, so plus 40 all over 2 times 5 is 10. So now that's going to equal negative 1 plus or minus the square root of 40 plus 1 is 41 all over 10. I would like for you to separate your answers. So x would be negative 1 over 10 plus or minus square root of 41 over 10. I'd like for you to separate your terms because that's going to help you later on when we get into can we simplify, do we simplify, and so forth. So try and separate. Even when separating, we cannot reduce, so we are done with that problem. So I'm going to circle number 9 for you to try as well. Bring me back the answer. So let's go ahead and do number 10 together. Well, when you look at number 10, it looks like it's factored. Parentheses 2x minus 5 times x plus 1 equaling 2. But the problem is it doesn't equal 0. If it equals 0, sure, but it doesn't. So what's the first thing we need to do? Distribute. It's not in any form that we can use to solve. So when I start distributing, 2x times x is 2x squared, and 2 times 1 is 2x. Negative 5 times x is negative 5x, and negative 5 times 1 is negative 5, and it equals 2. So at that point, we're going to combine like terms. So we have 2x squared minus 3x minus 5 equals 2. I'll need to subtract over the 2, so 2x squared minus 3x minus 7 equals 0. So now at that point, you could try the AC method, but it will not be factorable. So we're going to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So x equals negative 3, so it's going to be positive 3, plus or minus the square root of negative 3 squared, so that's why you have to make sure you use parentheses there, minus 4 times a is 2, times c, which is negative 7, all over 2 times a, and a is 2. So I want you to try and finish this one, and make sure you simplify correctly at the end. So I'm going to circle number 10. You're going to bring me back the answer during class time as well. Alright, number 11. Solve by completing the square. So hopefully this is a little bit of a review, but if not, let's learn it now. So solve by completing the square. If you look at the steps on the previous page, the first thing we want to do is have a and b on the left side and c's on the right. So we've already done that. So x squared plus 6x, leave some space, equals negative 1. Now the number in front of x squared is 1, so we can go to step 3. Step 3 then says take half of the b term, square it, and then add it to both sides. So half of 6 is 3, and 3 squared is 9. So I'm going to add 9 to both sides. So again, what did I do? I took the b term, which is 6, and you take half of it. So 6 divided by 2 is 3. And then I squared it, and 3 squared is 9, so I added 9 to both sides. Now again, the reason why we do those crazy steps is now this is a perfect square, so we could factor. Factors of 9 that add up to 6 are x plus 3 and x plus 3. So that would just be x plus 3 quantity squared equaling 8. So now we're at the square root property, which says if u squared equals d, we can take the square root of both sides, not forgetting plus or minus. So this is going to be x plus 3 equaling plus or minus the square root of 8. Now, make sure we can simplify the 8 as well. We're going to subtract over the 3, so negative 3 plus or minus square root of 8. We're almost done. 8 is 4 times 2, and the square root of 4 is 2. So x equals negative 3 plus or minus 2 square root of 2. One thing you might want to try is use this with and see if the quadratic formula gives you the same answer, because it should.